Hey guys, welcome to LeetCode. This is the second episode of a series of videos that solve LeetCode problems. If you plan to interview with companies like Google, Facebook someday, or you just solve algorithm problems for fun, don't miss it. So in the first episode, we talked about the most famous LeetCode problem, Tucson. It was a array string problem, and today we're going to talk about another array string problem, which is the LeetCode number 205, isomorphic strings. So the problem is, given two strings S and T, determine if they are isomorphic. Two strings are isomorphic if the characters in S can be replaced to get T. For example, if we have test cases string S egg, EGG, and T add, ADD, and paper, title, they both isomorphic. But if we have bar and foo, they're not. And if we have odd and add, they are. So if we have string egg and the string add, because E can represent A and G can represent D, so they are isomorphic. If we have string S paper and string T title, because P can represent T, A represent I, P represent T, E represent L, R represent E, so they are isomorphic. Let's try something not isomorphic, which is bar and foo. Because B can represent F and A can represent O, but when it comes to R, we've already got A to represent O, so R cannot represent O. So they are not isomorphic. So basically the problem is, if you can map a string to the other string, letter by letter, it means they are isomorphic. It's kind of like a dictionary. Does the idea of mapping and dictionary ring any bell? Sure it does. Hash table. So in the last episode, when we talked about the problem Tucson, I mentioned that never memorize solutions. Think about what is your goal and what data structure or algorithm can help you to achieve that. Apparently, the rules applies to all the problems. For this problem, our goal is to find the mapping between two strings, and the hash table data structure can help us to achieve that goal. Well, back to the problem. Let's walk through some test cases to see how it's going to work. For string egg and add, first, E to A, KE does not exist in the map, and the value A does not exist in the map. So it means there hasn't been any mapping for E and A for now, so we can just add them to the map. Second round, G to D. KG does not exist. Value A does not exist. So like the first round, just add G to D to the map. And the next round. Also G to D, KG exists in the map. Notice that if we find an existing key letter, we have to check if its value matches the value in the map. In this case, we check if letter G's value matches D, and it does, so we do nothing to the map and go to the next round. Since everything matches perfectly in the map, after looping the strings, we can return true. Egg and add are isomorphic strings. So this is a positive test case. For any problem, in order to complete the solution, we have to have at least one negative test case. So let's walk through string bar and string foo to find out how to decide if two strings are not isomorphic. First, we check B to F. Key B does not exist in the map, and value F does not exist in the map, so just add them to the map. And next round, A to O. A does not exist, O does not exist, so add them to the map. And next round, R to O. Even though the key R does not exist in the map, the value O does exist in the map as one of the values. It means letter O has been represented by another letter, and the letter is not R, so it fails isomorphic logic. We can just return false here. Well, that's pretty much the hash table solution for the isomorphic string problem. Before we dive into code implementation, let's not forget the time and space complexity for this solution. For people who are not familiar with time-space complexity, please watch the Big O video linked under our first episode. So the time complexity for this problem is O(n), because for two size n strings, we have to iterate every character in the string to find out if they are isomorphic. So the space complexity is actually O(1) because even if the length of the string, the n, might be very big, but the number of options for the characters is actually limited. Typically, we assume that the characters are within the range of ASCII, which means there are only 28 possible characters in the string, which means there are 128 keys at most in the map. So the space complexity is actually a constant. If you don't know about ASCII, go to the intro video I linked under the video. Now, let's see how to implement this solution in Java. First of all, I would like to check if string S and string T have the same length, because if they have different lengths, there is no way they are isomorphic. We can just skip the following logic and return false here. And then we initialize a hash map here. Remember I mentioned in the first episode when we talked about Tucson. So when you want to use data structure hash table in Java, use hash map instead, because hash map serves the same purpose and is preferred. And next, let's for loop these two strings to iterate every character in the strings. Char si represent the character in string S, position I, and char ti represent the character in string T, position I. Si is also the key for the map, and the ti is the value of the map. If map contains key si, we check if the value matches the current value in the map. If it does not match, return false. Else, if map does not contain key si, we check if there has been a value existed in the map. If it has, return false. If not, we simply add this key value pair to the map. After we've iterated the strings, if we haven't returned false, it means the isomorphic relationship is true, so we return true. Alright, that's the first solution for the isomorphic string problems. Remember, we mentioned the ASCII code earlier when we were discussing space complexity. So let's rethink our goal. Remember, know your goal first and think about what data structure or algorithm can help you to achieve that goal. So we need some data structure that serves as a dictionary, and the keys of the dictionary are in order, and the number of the keys is a fixed number, 128. Is hash table our only choice? Apparently not. Simply an array of size 128 can do the same. So let's see, we have this array indexed from 0 to 127. If we consider 0 to 127 as ASCII code, and the character accordingly will be A, B, C, D, E, F, G, 97, 98, 99 to 103. So for example, array A is actually the same as array 97. Let's use an example to walk through this solution. Say we have string S, egg, and a string T, add. And we keep two arrays of integers to keep record of the count of a character in that string. The first pair is E to A. The ASCII number for E is 101 and ASCII number for A is 97. As default, the array 1, 101 is 0 and array 2, 97 is 0. They are the same, so it means the count for occurrences for the two characters are the same. They are both 0. It means by now the two strings are isomorphic, so we simply add the count to our dictionary. The second pair are G to D. Same as the first pair. Their current counts are the same, 0, so simply add the current to our dictionary. The third pair are also G to D. Their current counts are the same, 1, so add the count to our dictionary. Now we can see they are isomorphic. But what if we change the test case a little bit? What if the string S is EGGF and the string T is ADDA? So the fourth pair would be F to A. We check the count for F in array 1, it's 0, and the count for A in array 2, it's 1. 0 does not equal to 1. It means the counts of occurrences for the two characters are not the same, so they cannot be mapped to each other. So they are not isomorphic. And we return false here. Well, as always, before diving into the code, what is the time and space complexity of this solution? Similar as a hash table solution, the time complexity is O(n) and the space complexity is O(1) because there are 128 characters in ASCII table and 128 is a constant. Now we can code this solution with Java. First, the same as hash table solution, check the length of the two strings. If not the same, just return false. And then, initialize two arrays of integers to store the counts of characters for string S and string T. And then, iterate the strings for the current character of S and the current character of T. If their current count are the same,
and
if all the characters for now the strings are isomorphic, so just edit the count and keep looping. But if the current counts for the two characters are not the same, means they cannot be mapped to each other, so the strings cannot be isomorphic, so just return false. And if all the characters pass the check after the loop, return true.
Well, that's all about LeetCode number 205, isomorphic strings. We use two solutions for these problems with the same time complexity O(n) and the same space complexity O(1). I hope you have a better understanding for the array string problem after this video. Please leave comments if you have any questions. Thanks for watching. If you like my video, please subscribe, like, and comment. This is LeetCode. I'll see you next time.